In this episode of Backer Breaks It Down, we take a look at some postulates and theorems. We are going to look at these by discovering them. So take a look at this diagram. This diagram shows 6 planes and multiple lines, rays, segments. There's a lot going on here, but we mainly have 6 intersecting planes. It kind of looks like a box, right? Look at points L and M. How many lines pass through both of these points? I only see one. I only see one line that goes through both of these points, and that would be the line LM. Okay. Next exploration. Identify where lines intersect each other. So start with just 2 lines. Where do they intersect? So I can use that line I already have highlighted, LM, and then I can look at any other line that intersects it. So how about I look at MP? What kind of geometric figure is the intersection of 2 lines? Well, those 2 lines are intersecting at M, so a point. These are our first 2 postulates in geometry. You have the points postulate. Through any 2 points, there is exactly one line, which is why we use 2 points, 2 letters, to name a line. Through any 2 points, there is exactly one line. And then our second theorem is the intersecting lines theorem, which says if 2 lines intersect, then their intersection is exactly 1 point. And that is exactly what we saw here in our little exploration. So, same diagram, that box made up of 6 intersecting planes. Now I want you to look at the points L, M, and N. So point L, point M, point N. How many planes pass through these 3 non-collinear points? Well, I really only see one, because then I have this plane here, L, M, N. There's only one plane that passes through those 3 points, which kind of makes sense because we know 3 non-collinear points determine a plane. Identify places where 2 planes intersect each other. All right, well, I've already identified that plane LMN, so now I'm just going to pick another plane that intersects that plane. So perhaps I go with this one on the side. Okay, so those 2 planes are intersecting one another. Think of that green one as being the ceiling in the room you're in now, and the yellow one as being a wall. So if you need a better visual, the green plane is your ceiling, and the yellow plane is a wall. What kind of geometric figure is the intersection of 2 planes? So once again, if you need to, you can look at your ceiling and your wall, and we can describe the intersection, because remember, this is infinite, as a line. So these 2 planes in our diagram intersect at a line. Your ceiling and your wall, I guess you would call it a segment, but remember, lines and planes are infinite. Okay, and so this brings us to 2 more postulates in geometry. The first one being the coplanar points postulate. Through any non-3, I totally said that wrong, I'm sorry. Through any 3 non-collinear points, there is exactly one plane. This word coplanar. So earlier we saw the word collinear, and I said co means together, linear like line. So coplanar would be together on the same plane. Right? But the 3 points have to be non-collinear. So in this diagram right here, the points A, B, and C, those are collinear. They're together on the same line. Whereas in the diagram below that, points A, B, and C are non-collinear. So if they are collinear, as they are in that first diagram, there's like multiple planes possible. They're showing 2 possible planes. Whereas in the diagram below, those 3 points are non-collinear, so they only make 1 plane. And then our last postulate is the intersecting planes postulate, which says if 2 planes intersect, their intersection is exactly 1 line. So your ceiling and your wall intersected in the corner, and that corner in geometry, we would refer to it as a line. And so those are the first 4 geometric postulates and theorems that you're going to see in this course, with many more to come.